Welcome back to Sleepy Orbits. It's late where you are, or early, which tonight is strangely fitting. And if sleep takes you somewhere in the middle of all this, good. That's exactly what these nights are for. Tonight, we're going to ask why the universe seems so quiet and follow the answer somewhere unexpected. In 2015, astronomers using the Hubble and Kepler space telescopes worked out something remarkable about our place in time. Of all the Earth-like planets the universe will ever make, in its whole long life, 92% have not been born yet. When our world formed, only 8% of the potentially habitable planets that will ever exist had formed at all. You've probably spent your whole life assuming we're latecomers, that the universe is ancient and we arrived near the end of the story, small and recent under very old stars. But here's the thing most people don't realize. The universe is not old, it's barely begun. The stars will keep forming for something like 100 trillion years. And against that calendar, 13.8 billion years is not the evening of the cosmos. It's the first hour of its morning. And that reframes the silence of the sky in the gentlest way imaginable, because there's a real scientific case, published, argued, taken seriously, that the reason we look out and find no one is not that we're alone at the end of things. It's that we're the first ones awake, wandering a house where the party hasn't started yet. Tonight, we'll walk that whole idea. The clock, the evidence, the trillion-year future of the small red stars, and what it would actually mean to be first. And I think by the end, the empty sky will feel less like an absence and more like an early morning that belongs to you. Now, let's begin. Start with the feeling itself, because everyone who has ever looked up at night knows it. The stars are beautiful, and the stars are silent, and the silence, if you sit with it long enough, begins to feel like a verdict. 60-some years of listening with radio telescopes as we explored on another of our nights together has returned nothing certain. No voices, no beacons, no visitors, and the usual ways of explaining that lean, dark. Maybe life is vanishingly rare. Maybe civilizations destroy themselves. Maybe something quiets them. We've told the silence's full story before, and tonight is not that night. Tonight belongs to the one explanation on the list that isn't dark at all, the one that gets the least airtime because it doesn't frighten anyone, and it goes like this. When you walk into a party and find the room empty, there are two possibilities. You've missed it, or you're early. And every clock in the cosmos, when you actually read the clocks, says early. The chairs are still stacked, the lights are half on. Somewhere in the back, the host is still setting up. The emptiness of the room isn't the emptiness of afterwards, dust and confetti and everyone gone home. It's the emptiness of before, tablecloths and quiet, and a whole evening still to come. Nothing about the silence changes in this telling. What changes is the tense. And tense, it turns out, is something astronomy can actually measure. So let's read the clocks, starting with the big one. because the entire argument tonight rests on a single question that almost nobody thinks to ask. How far along is the universe? Really? You know the age, 13.8 billion years, and it's a number that sounds like deep antiquity, and by every human measure, it is. But age only means something against a lifespan. A 13-year-old dog is elderly. A 13-year-old human is in middle school. A 13-year-old redwood tree is a seedling you could trip over. So, what's the lifespan of a universe, or at least of the living, shining phase of one? Cosmologists actually have an answer, and we visited its far end on other nights. The era of stars, the stelliferous era, the great age in which gas becomes suns and suns shine on worlds, does not run out when our sun dies or when the bright stars die. It runs as long as any star can still form and burn, and the smallest, thriftiest stars, as we'll see tonight, burn for trillions of years, with the last of them expected to gutter out something like 100 trillion years from now. 100 trillion. Hold that against 13.8 billion and do the one division that changes everything. The universe has currently lived about 1/100th of 1% of its star-bearing life. Not 1%. 1/100th of 1%. If you map the whole shining era onto a single calendar year, January 1st to December 31st, then right now, tonight, with the universe 13.8 billion years old, it is 12 or so minutes past midnight on New Year's Day. The champagne hasn't been cleared. The first sunrise of the year is 11 hours away. Every star that has ever shone, every galaxy ever photographed, every event we've explored across all our nights together, the whole of cosmic history so far, fits inside the first quarter hour of the year. And people look around at that first quarter hour and conclude the universe is old and dying and late. It isn't. It's an infant. We are not living in the twilight of creation. We're living so close to the beginning that, cosmically speaking, the Big Bang is still ringing in the room's ears. And if that feels impossible, if 13 billion years refuses to feel like a beginning, here's the comparison that makes it click. Think of Earth. Our planet is 4.5 billion years old, a third the age of the universe itself, and for almost all of that span it was busy but quiet. Oceans, microbes, slow chemistry. Complex animal life is roughly 500 million years old, a ninth of Earth's story. Humans with language, a few 100,000 years, a rounding error. And radio telescopes, the tools that let us notice the cosmic silence at all, less than 1 century. The pattern, everywhere you look, is the same. Interesting things take enormous run-ups. The universe spent its first stretch making the ingredients, as we'll see in a moment, spent billions of years more making enough worlds, and has only just, in the most recent flicker, produced at least one place where matter sits up in bed and asks what time it is. We are that flicker. And the honest answer to our own question, what time is it, is the answer nobody expects. It's early. It is so early that asking where everyone is may be like waking at 4 in the morning in a silent house and concluding from the stillness that the human race has ended. The house isn't dead. The house is asleep. The alarm clocks, most of them haven't even been built yet. Before we go further, let's walk the calendar properly, both versions of it, because the numbers tonight are too large to feel without a map, and the map was drawn beautifully half a century ago. Carl Sagan popularized the device, the cosmic calendar, and it goes like this. Compress the entire history of the universe so far, all 13.8 billion years, into a single year, the Big Bang at the stroke of midnight on January 1st, this very moment, as midnight at the end of December 31st. On that calendar, every day is 38 million years. And the year unfolds like this. January and February belong to the Dark Ages and the first stars, the barren giants forging the first heavy atoms. The Milky Way assembles itself through the spring, and then, for month after month, the universe simply works, stars living and dying, the pantries stocking, summer passing in galaxies beyond counting. Our sun doesn't ignite until the 1st of September, 2/3 of the way through the year, condensing with its planets out of thoroughly recycled ash. Life appears on Earth by late September, single cells in dark water, and then does almost nothing visible for 2 full months, which we'll come back to, because that pause is one of tonight's secret protagonists. The first complex creatures arrive in mid-December. The dinosaurs walk on Christmas Day and vanish the morning of December the 30th, and everything human, everything, fits inside the final evening of New Year's Eve. The first upright walkers appear around 10:30 at night on December the 31st. Fire is tamed a few minutes past 11. All of recorded history, the pyramids, Rome, every empire, every book, every name you know, occupies the last 14 seconds before midnight. The life you are living tonight is happening in the final fraction of the final second of the year. That's the famous calendar, and its usual lesson is humility. We are latecomers, brief and small, arriving at the very end of an immense story. But tonight, we've learned the trick, hiding in it, and the trick changes the lesson completely. Sagan's calendar ends at midnight tonight because that's all the history there is so far. It's a calendar of the past. And calendars of the past always make the present feel like an ending. So draw the other calendar, the one from earlier tonight, the full year of the stars, January 1st at the Big Bang, December 31st when the last star gutters out 100 trillion years from now. On that calendar, the complete story of the universe so far, the entire famous year we just walked, every galaxy, every dinosaur, every second of human history, all of it together, compresses into the first 12 minutes of January 1st. The sun ignites at 8 minutes past midnight and burns out before 1 in the morning. Everything Sagan mapped is the year's opening credits, and the rest of the calendar, the true bulk of it, spring, summer, autumn, the long crowded seasons when the red embers rule and the worlds are countless, is blank. Not dark, blank, unwritten, waiting. Two calendars, same universe. One says you arrived in the last second of the story. The other says you arrived in the first minutes of it. And the difference between them is just this: whether you count only what has happened or count what will. The universe, which will get to live both calendars, has no doubt which one is true. Since tonight's hero is the first star, let's go and witness it, the way we visit everything on these nights, because there is no scene in all of cosmic history more deserving of the trip. Set your impossible ship adrift about 70 million years after the beginning, in the heart of the Dark Ages, and look around and understand that looking around is exactly what fails. There is nothing to see, not dim things, nothing, no stars anywhere in the universe, none, not one, no galaxies, no glow, no reference points, an entire cosmos of warm hydrogen fog cooling in the dark, in every direction, for millions of years in every direction. The only light that exists is the afterglow of the beginning itself, and it has stretched by now out of the visible entirely, sunk into infrared warmth your eyes can't catch. It is the deepest, most complete darkness that has ever existed or ever will. Because it isn't the darkness of shadow or distance, it's the darkness of a universe that has not yet invented the lamp. And yet the room isn't still. Drift with the fog and feel the pull under everything, because gravity is awake. Has been awake since the first instant, patiently gathering the slightly denser threads of the fog into slowly deepening pools, the invisible scaffolding drawing everything down its slopes, exactly as it would later draw raindrop galaxies down the watershed of immense heaven. In one of those pools, ahead of all the others, the hydrogen is thickening, warming as it falls, fighting to cool and falling further. A knot tightening over spans of millions of years, glowing faintly now in wavelengths. Nothing exists to see, contracting, contracting, until the center of the knot crosses the ancient threshold, the same one our sun would cross 10 billion years later, and ignites. And there it is, somewhere in the endless fog, without witness, without sound, a point of true light switches on. The first fusion fire in the history of everything, a star, probably a monster by our standards, huge and furious and blue beyond blue, flooding its cradle with the universe's first starlight, throwing the universe's first shadows, and around it, for millions of light years in every direction, the fog remains absolutely dark, unaware. The light still crawling outward with its news. Hold that image, one star alone, in an unlit universe, because it is the purest picture of firstness that will ever exist, and every theme of tonight is standing inside it. It could not know it was first. It could not see that it mattered. It burned in total solitude a few million years and died in the universe's first supernova, seeding the fog with the universe's first heavy atoms, the opening donation to the pantry that would someday build worlds, oceans, and listeners. It was never lonely, whatever that word could mean for a star, but it was alone, the way we may be alone, completely, temporarily, and generatively, the solitude of the first mover, whose whole function is to make solitude impossible for everything that follows. Within a few 100 million years, its descendants, numbered in the billions and the dark ages, were over, forever. There has never again been a moment without starlight, and there never will be, until the year of the stars runs out. Every night sky since, including the one above your roof right now, is the long echo of that one ignition. We came from that kind of first. We may be that kind of first. And if we are, the job description hasn't changed in 13 billion years. Burn, seed, and end the dark ages of your particular kind of light. Now, a fair listener should push back here, because there's an obvious objection. If the universe is so young, why couldn't life have started even earlier? Why aren't there civilizations 10 billion years our senior, ancient beyond imagining, filling the sky with their monuments? It's a good question. And the answer is one of the most satisfying pieces of the whole puzzle, because it turns out the universe could not have made us, or anything like us, much earlier than it did. The delay wasn't laziness, it was chemistry, and the chemistry had to be manufactured. Rewind to the beginning, to the first minutes after the Big Bang, and take inventory of what existed. Hydrogen, helium, a whisper of lithium. That's the complete list, and you cannot build a rocky planet out of it, cannot build oceans, bones, circuit boards, or bedtime listeners. Every atom that matters to you personally, the carbon in your cells, the oxygen in your lungs, the iron in your blood, the silicon in the rock beneath your city, the calcium in the hand resting on your blanket. None of it existed anywhere in the universe on day one. All of it had to be forged. And as we learned in our Museum of Catastrophes, the forges are stars, and the delivery method is their deaths. The first generation of stars condensed from pure hydrogen and helium, enormous, brilliant, and chemically barren, and they lived fast and detonated, seeding the gas with the first traces of heavier elements. A second generation, formed from that faintly enriched gas, brewed more, died, and seeded again. It took generations of this, stellar lifetimes stacked end to end, before any cloud of gas anywhere contained enough rock-making, life-making material to condense a world like ours. Earth is not built from original matter. Earth is built from ash, refined through at least 2 rounds of stellar furnaces, and refining takes billions of years. No shortcuts, no rushing the ovens. Which means the universe has a habitability start line, an earliest possible date for worlds like ours, and we can sketch where it falls. For the first few 100 million years, no stars at all, just cooling gas and darkness, the cosmic dark ages. Then the first stars, the barren giants. Then a long ramp of enrichment, different neighborhoods filling their pantries at different rates, the dense hearts of young galaxies stocking up fastest. By perhaps 2, 3, 4 billion years in, The earliest, genuinely Earth-like planets become chemically possible in the luckiest locations, though those early neighborhoods were also, as our museum night showed, ferociously violent, quasars blazing, collisions constant, gamma-ray bursts far more common than today. Not the address a young biosphere wants. The comfortable era, calm galaxies with rich chemistry, really opens somewhere in the middle, billions. And Earth formed 9.2 billion years in. Run those numbers side by side and something surprising emerges. We are not stragglers who arrived eons after the doors opened. The doors opened, cosmically speaking, not long before we walked through them. There may have been a first wave with a head start of 1 billion or 2 years in rare, charmed corners. And that's a genuine window for elders. But the deep time picture, the 10 billion-year-old empires of science fiction, runs headlong into the pantry problem. Go back 10 billion years and you're in a universe still stocking its shelves, still too poor in atoms and too rich in explosions for comfort. The universe did not keep life waiting out of neglect. It was cooking as fast as chemistry allows. And on the honest timeline, we're not the guests who overslept and missed everyone. We're among the earliest arrivals it was physically possible to serve, and we know this, in part, because we can now literally watch the preparation happening, which is a gift no other generation of humans has had. The James Webb Telescope, our companion on so many of these nights, has photographed galaxies as they were less than 300 million years after the beginning. The actual dawn, the barren first kitchens, hydrogen bright and metal poor, no possibility of planets like ours anywhere in frame. When we look at those images, we are seeing the era that explains our own earliness, the long prologue during which nobody, anywhere, could yet exist. The silence of the modern sky and the emptiness of those dawn photographs are the same fact, read at 2 different times. First, the universe had to make the ingredients, then the worlds, then the run-ups, and it has only just now, finished the first batch. And there's a second delay to account for, quieter than the chemistry, but just as binding, and our own planet is the only worked example anyone has. Even once a world exists, warm and wet and stocked with every needed atom, life takes staggering amounts of time to become anything. And Earth's biography is a masterclass in slowness that's worth telling on its own terms. Life here started fast. That's the striking first fact. The oceans were barely finished before the first cells appeared, within a few 100 million years of the surface becoming livable, which hints, encouragingly for the universe at large, that simple life may begin easily wherever conditions allow. But then came the wait. For roughly 2 billion years, half the planet's entire history, life stayed single-celled and microscopic, oceans of bacteria doing chemistry, and nothing else, no shells, no leaves, no eyes, 20,000 times longer than humans have existed, spent entirely on invisible groundwork. And the groundwork mattered. The early microbes that learned to harvest sunlight began exhaling oxygen, a gas the planet had never held, and it took the better part of 1 billion years just for that oxygen to stop being swallowed by the rocks, rusting the world's iron out of its oceans before it could even begin to fill the air. Geologists half-jokingly call one long stretch of this era the boring billion. 1 billion years in which, by the visible record, almost nothing happened. And that's the deepest lesson in the archive. 1 billion years of apparent nothing was, in fact, the patient assembly of an oxygen-rich, energy-rich world, the only kind that can afford animals. Because oxygen is the fuel of ambition, biologically speaking, and only after it saturated the seas did the famous fireworks finally come. The Cambrian explosion, 500 million years ago, when complex bodies burst into the fossil record in mere tens of millions of years, eyes and spines and hunters, and everything after. The last 1% of the story sprinting to us. Add it up, and Earth spent 9/10 of its history preparing, and 1/10 flourishing. 4 billion years of run-up for 500 million of visible life. And here's why that arithmetic belongs at the heart of tonight. It means a habitable planet is not enough. A habitable planet needs to stay habitable, continuously, uninterrupted, for billions of years, through asteroid eras and ice ages, and its own star's slow brightening, before it can produce so much as a trilobite, let alone a listener. Time isn't one ingredient among many. Time is the expensive ingredient, the one the universe's early eras simply could not yet supply, because the calm hadn't lasted long enough anywhere. And it means the young universe's silence has a second, deeper flaw beneath the chemical one. Even the earliest possible worlds, formed in the earliest charmed corners, would then need their own 4 billion year run-ups, their own boring billions, their own patient rusting of oceans before anyone stood on them wondering about the quiet. Stack the delays, the elements, the calm, the run-up, and the earliest anyone could plausibly be wondering is not long, cosmically, before we started wondering. The silence stops being spooky and starts being arithmetic. Life is not late to the universe. Life is exactly as early as physics, chemistry, and 1 boring billion at a time permit, and we are what on schedule looks like from the inside. It's worth remembering, too, how long humanity has been asking tonight's question, and how recently we acquired the one piece the ancients never had. The dream of other inhabited worlds is genuinely old. Ancient Greek atomists argued for innumerable worlds as a matter of logic. In the 16th century, the philosopher Giordano Bruno preached an infinity of suns with an infinity of earths, and paid for that, and much else with his life. By the 1600s, after the telescope made the planets into places, popular books imagined inhabitants for every world in the solar system. And by the 19th century, serious astronomers mapped illusory canals on Mars and proposed signaling the Martians with giant mirrors and geometric wheat fields. The conviction that the universe must be inhabited is one of the most persistent ideas our species has ever held. What nobody had in all those centuries was a clock. The universe of Bruno, and even the universe of the canal mappers, had no known age, no beginning Étienne could date, No timeline on which to place ourselves early or late. Worlds were either inhabited or empty. The question was where, never when. The modern version of the hunt began in 1961, when the astronomer Frank Drake gathered the first ever scientific conference on extraterrestrial intelligence and, needing an agenda, wrote a simple chain of factors on a blackboard: the rate of star birth, the fraction with planets, the fraction of those habitable, the fraction where life starts, then intelligence, then technology, and finally how long civilizations last. The Drake equation, it's called now, and it has organized the entire conversation for 60 years, a machine for turning ignorance into a to-do list. But notice, with tonight's eyes, the assumption built silently into how the famous equation gets used. Every term is treated as a property of the universe, as if the answer were a constant, as if the number of civilizations were a fact about the cosmos the way its temperature is. Tonight's two papers say otherwise. Nearly every term in that chain is a function of time. The star birth rate has fallen tenfold since cosmic noon and will glide on for trillions of years. The fraction of stars with living planets depends on how many worlds exist, 92% pending. The odds of intelligence depend on how many run-ups have had time to finish, almost none so far. Ask Drake's question in the era of the red embers 10 trillion years from now, and the same equation, the same universe, returns an answer perhaps thousands of times larger than it returns tonight. The equation was never broken. It was asked at one instant of a 100 trillion year experiment and mistaken for the final score, like polling a stadium an hour before the gates open and concluding the sport is unpopular. Bruno guessed the worlds were infinite. Drake built the ledger to count them. And our own era's contribution, the one the textbooks will remember this century for, may simply be the clock. The realization that the census of the living universe has a date on it, and the date we've been sampling is the first page. So the past couldn't hold much company. The real question is the future, and this is where the 2015 study enters, the one from the top of the night, and it deserves telling properly because its logic is so pleasingly physical. Two astronomers, Peter Baruzzi and Molly Peoples, working with the Hubble and Kepler archives, set out to draw the universe's birth curve, the complete history and future of planet formation, and their method was essentially cosmic accounting. Hubble's deep surveys tell you the history of star formation across all of time, and it has a famous shape. Star birth rose steeply from the Dark Ages, peaked hard around 10 or 11 billion years ago, an era astronomers call cosmic noon, when the universe was forming stars perhaps 10 times faster than today and has been sliding gently downhill ever since. Read only that curve and you'd conclude the party is winding down. Most stars that will ever exist are already born. Last call approaching. But Baruzzi and Peoples read the other side of the ledger too, the fuel gauge. How much star-making gas remains in the galaxies and in the vast reservoirs between them? And the answer is most of it. The universe has used only a modest fraction of its raw material. The current era's slower pace isn't a kitchen running empty, it's a kitchen pacing itself, and the slower burn stretches the remaining fuel across a future so long that the total keeps compounding. Fold in Kepler's census of how often stars make Earth-sized worlds in temperate orbits, run the whole calculation forward, and out comes the number that started tonight. At Earth's birth, 8% of the habitable worlds the universe will ever make existed. Even today, the overwhelming majority remain unborn. 92% of the Earths are still in the pantry, waiting to happen, most of them destined for eras and neighborhoods far downstream of us, in the long, slow trillions when the small stars rule. Sit with what that means for the question of company, because this is the pivot of the whole night. Every estimate you've ever heard about life in the universe, every version of the famous Linear arithmetic, quietly assumes we're sampling a mature universe, that the worlds are mostly built and the dice have mostly been rolled. The birth curve says otherwise. The dice have barely started rolling. If habitable worlds are the lottery tickets of life, then at this hour of cosmic time, 92% of the tickets haven't been printed, let alone scratched. Asking why we haven't met anyone may be like standing in a stadium an hour before the gates open and wondering why the seats are empty. The event is real. The crowd is real. The crowd is simply in the future. And there's a lovely local footnote to this. The calculation says our own galaxy, the Milky Way, still holds enormous reserves of gas and will keep making worlds for eons. But the deep future of planet birth belongs even more to the small galaxies, the dwarfs, the unhurried places that have barely touched their fuel. The great spirals were the sprinters of cosmic noon. The little galaxies are the marathoners, and the marathon has 100 trillion years to run. When the universe's true crowds arrive, most of them won't even live in galaxies like ours. They'll live in the quiet little ones, the cosmic villages under stars that, at this present hour, are clouds that have not yet begun to fall. There's a spatial version of tonight's whole argument too, a where to go with the when, and it completes the picture in a satisfying way. Just as the universe has habitable eras, a galaxy has habitable neighborhoods, and astronomers in the early 2000s began mapping what they called the galactic habitable zone, the ring of a galaxy where worlds like ours are actually possible. The logic runs on two gradients working against each other. Toward the galactic center, the pantry problem solves itself early. Stars are packed dense and the heavy elements accumulated fast. Plenty of planet-making material, but the density is the curse. Because downtown, as our museum night showed, is where the violence lives. The supernovae elbow to elbow, the gamma ray bursts, the raining monster itself, sterilizing neighborhoods on schedules too short for run-ups. Toward the galaxy's outskirts, the calm is perfect and eternal, but the pantry never filled. The outer disk is metal poor to this day, short on the atoms that rock and blood require. In between lies the ring of balance, enough chemistry, enough calm, and our sun orbits squarely inside it, about 2/3 of the way out, in the galactic suburbs, which by now should sound familiar, because every scale of tonight's story keeps handing us the same address. Early in the era of possibility, middling in the ring of possibility, the suburbs of space and the dawn of time. But here's the detail that folds the where back into the when, and it's the part I find quietly wonderful. The galactic habitable zone is not fixed, it grows. Every generation of stars pushes the chemical frontier outward, enriching gas that was too pristine, while the galaxy's violence, its star-forming fury and its bursts, slowly calms with age, taming neighborhoods that were too wild. The models show the comfortable ring-widening era by era, spreading inward as the violence fades and outward as the pantries fill, until, in the deep future, our whole night has pointed toward most of the galaxy is habitable most of the time. The universe doesn't just have most of its worlds ahead of it, it has most of its safe places ahead of it too. Space itself is mellowing at every scale, on the same long schedule as everything else in tonight's story, and the galaxy our descendants or successors inherit will be gentler, richer, and roomier than the one outside your window, which is, itself, already the gentlest it has ever been. We are early even about the good weather. And then, 1 year later, a second paper pushed the argument to its astonishing conclusion, and this one came from Harvard, from the astrophysicist Abraham Loeb and his colleagues, and it asked the boldest version of tonight's question directly. Across the entire lifetime of the universe, past and future, when is life most likely to exist? Not where, when. Their approach was beautifully simple at its core. The main thing a planet needs beyond existing is time, a long, stable stretch of warmth from a well-behaved star. Because if Earth teaches anything, it's that biology is slow. 4 billion years from first cells to first astronomers, on a world whose star grants about 10 billion total. So, the master variable is stellar lifespan, and stellar lifespans, as we've seen across so many nights, are savagely unequal. The big bright stars spend their fuel like sailors on leave and die in millions of years, far too fast for biology to get past the starting line. Sun-like stars grant 10 billion, enough, evidently, but with little to spare. And the small red dwarfs, the humble embers, 3 of every 4 stars in the sky, the Proximas, hoard their fuel so miserly that they will burn steadily for trillions of years. A red dwarf of 1/10 the sun's mass shines for something like 10 trillion years. 1,000 of our sun's lifetimes, a stretch of stable warmth so long that evolution could run its entire Earth story 1,000 times over, back to back, and still have fuel remaining. Loeb's team folded the star lifespans, the birth curve and the habitability windows into one integral, the relative likelihood of life across all cosmic time. And the answer came out lopsided beyond anything in tonight's story so far. The probability of life peaks around small red dwarf stars roughly 10 trillion years from now, and life in that far era is about 1,000 times more likely than life now. 1,000 times. On the graph of living things across the history of the universe, the great mountain of life rises trillions of years downstream. And the present, our vivid, crowded, feels like everything present, sits in the flat lowlands at the very left edge, in the foothills before the foothills. If that graph is right, then existence at our hour of cosmic time makes us, in Loeb's own word, premature. Life, born before the era of life. A candle lit hours before the fireworks. First. Now the paper is honest about its hinge, and tonight will be too, because the whole trillion-year promise depends on one open question that you, dear listener, already know intimately from our journey to the nearest star. Are red dwarfs actually habitable? The small stars are patient, but as we saw with Proxima, they are not gentle. They flare, they scour, and their planets huddle so close, tidally locked, that atmospheres may be stripped before the long, calm eons arrive. If red dwarf worlds generally survive their star's violent youth and keep their air, the calculation stands and the future owns essentially all of life, and we are among the very first. If red dwarfs sterilize their worlds, the mountain on the graph collapses, sun-like stars are the only real homes, and our timing becomes not early but ordinary. One lamp among whatever lamps the Middle Era manages. And here's the part I love. This is not a question for philosophers. It's the exact question that telescopes are working on right now, tonight. The Webb telescope taking the temperature of the little worlds around red dwarfs like the TRAPPIST system, checking whether they kept their atmospheres, and the answer, expected within years, not centuries, will quietly determine which universe you're falling asleep in. One where life's story is nearly all ahead, or one where the neighbors, whoever they are roughly our own age. Either answer is gentle, but only one of them makes you the first line on the first page, and at this moment, nobody on Earth knows which it is. Since the whole future may belong to the small stars, let's visit the real estate properly, because the red dwarf worlds we've already found are among the most evocative places in the catalogue, and they are, if tonight's argument holds, the drafts of the universe's main setting. The showcase is a system called TRAPPIST-1, 40 light-years away, a red dwarf so small and cool it's barely a star at all, scarcely larger than Jupiter in girth, glowing the deep color of embers. Around it, in 2016 and 17, astronomers found not one planet, but seven rocky, roughly Earth-sized worlds, and the system's architecture is like nothing near our Sun. All 7 orbit closer to their star than Mercury does to ours, their years lasting between a day and a half and 19 days, packed so tightly that from any one of them, the neighboring planets hang in the sky not as dots, but as disks, the way our moon does, worlds watching worlds. 3 or 4 of them sit in the temperate zone where liquid water is possible. And because the star is so dim, that temperate zone is a tight huddle around the fire. which means every one of those worlds is almost certainly tidally locked. One face in permanent day, one in permanent night, and all the strange twilight geography we walked on Proxima b, the ring of eternal sunset, applies there sevenfold. Now add tonight's ingredient, time. TRAPPIST-1 is already older than the sun, and it has barely begun. It will still be shining, essentially unchanged, when the sun is a fading white dwarf and this entire era is deep prehistory. Whatever chances those 7 worlds have, they get to keep rolling the dice for trillions of years through stretches of stability our solar system could never offer. If atmospheres survive there, and that is exactly what the Webb telescope is testing on these very worlds right now, then systems like TRAPPIST-1 aren't curiosities. They're the template for where most of the universe's life will someday live, crowded little families of twilight worlds huddled around patient embers with all the time in the world, and then 1,000 times more. And it reframes our own neighborhood too, one more time. Proxima, the little flare star next door, the ember we met on the way to Alpha Centauri, holds at least one temperate zone world, and Proxima will outlive the sun 100-fold, which means the nearest candidate for the universe's long biological future is also the nearest star to your bed. If the red dwarfs come through, if their tantrums fade and their worlds keep their air, then when the far era arrives, the era of the Great Mountain on Loeb's graph, one of its quadrillion homes may be the small red light 4 1/4 light years from where you're lying, the same unreachable neighbor whose distance we spent a whole night measuring. We keep circling back to the same few stars on these journeys, and they keep changing meaning. The dead ends become doorways. The neighbor we can never visit may be the address where 10 trillion years from now, somebody finally lives. Here's something to carry outside the next clear night, because tonight's story is written in your own sky, in an ink most people never notice. And once you see it, you can't unsee it. Go out and look up at the stars. The couple of 1,000 points a dark sky offers the naked eye, and ask the innocent question, what am I actually looking at? The answer is a systematic illusion. Essentially, every star you can see without help is a giant, a rarity, one of the sky's celebrities. The blazing blues, the swollen reds, the unusually bright sun-like minority, visible precisely because they are exceptional. And the actual majority of the universe, the red dwarfs, the patient embers who make up 3 of every 4 stars, the future's landlords, every single one of them is invisible to your eyes. All of them. There is not one red dwarf in the sky bright enough to see unaided, not even Proxima, the closest star that exists, 4 1/4 light years away and still 50 times too faint. The night sky is a gallery of the loud and the doomed, the stars that burn hard and die young, while the quiet, trillion-year multitude, the ones who will inherit and host nearly everything, hang unseen between the bright ones, everywhere, outnumbering everything you can see by orders of magnitude. Your eyes, in other words, were built to see the universe's brief aristocracy and miss its enduring population. And every generation before ours mistook the visible sky for the actual universe, which is forgivable because the actual universe hides. So here's the reframe for your next night under the stars. The sky you can see is the universe's present, bright, dramatic, and passing. The sky you can't see, the dark spaces between the stars filled with invisible embers, is the universe's future, and it is overwhelmingly larger. When you look up, you're seeing the opening act, lit and loud, while the main cast waits everywhere in the dark. And the dark, for once, is not empty distance. It's the crowd that hasn't taken the stage. Even the emptiness between the visible stars, tonight of all nights, deserves a second reading, because that's where nearly everyone who will ever live is going to live, around lights too humble for your eyes, in a future too long for your calendar, next door to everything you can see and completely hidden from it. The universe keeps its future the way it keeps its distances, in plain sight, invisibly. And now you know where to look for it, which is everywhere you can't. Now let's take the idea seriously and walk around inside it, because if the clocks are telling the truth, if we really are among the first, then several familiar things quietly change their meaning, and the first is the silence itself. All our lives, the empty sky has been framed as a verdict on us, evidence of rarity, fragility, doom. Take your pick from the dark menu. But run the earliness argument and listen again. If the universe's great age of life lies trillions of years downstream, then the present silence is exactly what a healthy, on-schedule universe should sound like at this hour. You are not hearing a graveyard. You are hearing a nursery before the children exist. The profound quiet of a house where the cribs are still being assembled. Nothing has gone wrong out there. Nothing has died. The silence isn't the sound of after. It's the sound of not yet, and those are opposite sounds that happen to be identical, distinguishable only by knowing the time, which, as of the last decade, we finally, tentatively, do. And the second thing that changes meaning is us, everything we've ever made and sent. Think of the golden records, the 5 little spacecraft we watched leave forever on our Alpha Centauri night, drifting outward with their greetings and their music, unanswerable letters mailed to no address. In a crowded, ancient universe, those are latecomers' gestures, minor additions to a conversation long running. But in a young universe, in the first hour of the year, they become something else entirely. They become the oldest artifacts of the future. If life truly blooms across the red dwarf eons, then everything of ours that survives, the drifting probes, the thinning bubble of century-old radio whispering outward at light speed, even the chemical fingerprints we've pressed into our planet's rock, becomes, to that unimaginable posterity, what cave paintings are to us, except older, incomparably older, relics from the first flicker of the first morning, made by the ones who were awake before anyone. The 5 bottles in the ocean don't change. The ocean changes. We thought we were writing to elders who never answered. We may have been writing to descendants who haven't been born. And there's a duty hiding in that thought, gentle but real, which philosophers of the far future have begun to take seriously. Firstborns matter disproportionately, not because they're better, but because they're upstream. In any long family story, the earliest members cast the longest shadows. Their choices echo, their survivals matter most, because everything after either descends from them or remembers them. If the universe's story of life is 100 trillion years long, and we are in its first hour, then the things that happen here on this one small world in these few fragile millennia sit at the headwaters of something incomprehensibly vast. Perhaps life arises independently everywhere in due time, and we're just the first bud on a tree that was always going to blossom. Or perhaps, and no one can rule this out, the spark is rare, and whether the great future is a garden or a vacuum depends on whether the first flicker keeps itself lit through its own early storms. Either way, being early is not a diminishment, it's the opposite. The empty sky doesn't mean we arrived at a party that failed. It may mean we arrived so early that we are, without ever asking for the job, the hosts, the ones who turn on the lights, the ones the crowd, when it finally arrives, will have arrived after. Let's visit them, the crowd of the deep future, in the way only these nights allow. Come forward 10 trillion years to the top of the great mountain on the graph, the biological prime of the universe, and stand on a world of that golden age. It orbits a small red star, of course, nearly all of them do by now, a patient ember that has burned without complaint for longer than 1,000 histories of our entire universe so far, and will burn as long again. The world sits in the twilight ring we know so well, tidally locked, one face warm, one frozen, its cities and forests, or whatever grows in their place, gathered along the band of eternal sunset, under a huge dim red sun that never moves in the sky. By every measure that matters to biology, this is the good era, the crowded era. If the calculations we walk tonight are right, worlds like this one are 1,000 times more common as homes for life than worlds of our era ever were. And the universe around this world has had time, endless time, for every slow miracle to finish happening. And now look up through their eternal evening at their night sky and receive the strangest gift of tonight. It's almost empty, far emptier than ours, because 10 trillion years is deep into the age of separations we've visited before. The expansion, the widening river from our great attractor night has long since carried every distant galaxy beyond every horizon. Whatever galaxy this world inhabits by then, long merged with all its neighbors into one great slow swarm of old red stars, is, as far as its sky can testify, the only object in existence. No deep fields for their telescopes, No cosmic dawn to photograph, that light left forever ago. No background hum of the beginning, stretched by then beyond any instrument's hearing. The universe's crowded age is also its forgetful age. They will inherit everything except the evidence. Their scientists may deduce from subtle clues that there was once more, or they may build cosmologies of one island in an infinite dark and be wrong through no fault of their own. The truth about the beginning, the expansion, the 100 billion galaxies, the whole story we can simply look up and see, will be, for them, somewhere between hard-won inference and lost myth. Now hold the two eras side by side, theirs and ours, because this is the trade at the heart of tonight, and it's the fairest trade I know of in all of cosmology. They get the company, we get the view. They live in the universe's summer, life everywhere, time without end, under skies that tell them nothing. We live in the universe's first morning, nearly alone, brief, fragile, and the entire story is visible from our window. Every galaxy still in sight. The first light of creation still detectable, humming in every direction for anyone who builds the right antenna. The whole family album, dawn photographs included, open on the table. Astronomers sometimes point out, with a kind of awe, that we live in the single best era for cosmology there will ever be. Early enough to see everything, late enough to understand it, and that window is not permanent. If you could choose your seat in the 100 trillion year theatre, the crowded golden eons or the empty brilliant dawn, there's a real argument, a serious one, that we hold the best tickets that will ever be printed. The price of those tickets is the silence. The seat comes with an empty row, but it faces everything, the entire stage at the 1 hour of the performance when all of it can still be seen, and somewhere 10 trillion years from now, a mind on a twilight world reconstructing what its sky can no longer show would give anything to sit where you're lying right now. And since tonight keeps gesturing at the 100 trillion years, let's actually walk them once, gently, the whole staircase of the future, because regular listeners have visited some of these landings on other nights, and tonight is the night they all connect. The era we live in now, the stelliferous era, the age of stars, runs from the first star to the last, and we're 12 minutes into its year. Within it, the near landmarks you already know. Our sun has 5 billion good years left, then the swelling, the white dwarf, the long cooling. The Milky Way and Andromeda merge around the same era into the great calm elliptical we've called Milkomeda, which will then drift, as our great attractor night taught, into a sky slowly emptying of galaxies as expansion carries the rest beyond every horizon. The bright stars die out era by era, the yellows after the blues, the oranges after the yellows, and the sky's lights redden and dim and thin, until, some 10 or 20 trillion years along, the universe settles into the age tonight's whole story points toward, the red dwarf noon, the longest living era there will ever be. Trillions upon trillions of years of small patient suns warming small huddled worlds, the mountain on the graph, The crowd, the golden age of biology, run at ember light. Then even the embers begin to gutter. Around 100 trillion years the gas is spent, the last new star flickers on somewhere, burns its trillion years and goes out, and the year of the stars ends. What follows we toured on our black hole night, the degenerate era, the endless dark filled with cooling white dwarfs, drifting neutron stars and the 100 million sleepers, now inheritors, the black holes cruising a lightless cosmos as its last great structures, radiating their slow quantum whisper for spans that make everything before look like a spark. 10 to the 67 years and beyond, the black hole era, and after even them, the dark era, the near nothing stretching on without end. I don't walk you down that staircase to chill you, quite the opposite, and here's why it belongs in tonight's story. Notice where all the life is. Every era in which anything can plausibly live, every warm world, every twilight ring, every buried ocean sits in the first landing of that staircase, the star year, the first 100 trillion, and within it, the crowded seasons lie ahead of us, not behind. The universe's structure, read as a whole, is a brief, brilliant spring followed by an unbounded winter. And we are not merely inside the spring, we are inside the spring's first morning, before almost all of its flowers. Whatever melancholy the far winter carries, and on other nights we've made peace with it, tonight it serves one purpose only: scale. It's the dark frame that shows the painting's true size. The age of life is finite, and it is almost entirely undone. The universe holds one great season for living things. It has barely begun, and you, awake tonight in its first hour, are not attending the end of anything. You're attending the part every later age will call the beginning, and would trade anything to have seen. One more landing on the staircase deserves a lamp of its own before we close, because the long future isn't only for strangers around distant embers, and this part of tonight's story almost nobody has heard. Our own sun gets an afterlife. When the sun's bright career ends 5 billion years from now, the swelling, the shedding, the quiet settling into a white dwarf, the story, as it's usually told, stops there. An ember cooling forever, the lights out at home. But run the physics forward and something lovely emerges. A white dwarf is not instantly cold. It's a planet-sized jewel of compressed matter that begins its retirement hotter than the sun's surface is now, and then cools with magnificent slowness over not millions but trillions of years, spending eras longer than the current age of the universe at each gentle temperature on its way down. Which means the dead sun will still have a habitable zone, a tiny one, a tight ring of warmth close in, closer than Mercury flies today, but real and enduring in its slow cooling way for spans that dwarf the sun's entire living career. And worlds can end up there. Astronomers have already found planets orbiting white dwarfs, whole and close, migrated inward or captured after the violence. And in 2020, a telescope caught an intact giant planet circling a white dwarf snugly inside just such a zone. There is even a wistful calculation in the literature showing that a world parked in the dead sun's warm ring could stay temperate for something like 10 trillion years, matching the red dwarf's year for year, warmed not by fusion, but by the long exhale of stored heat, a hearth fire economy instead of a furnace one. The age of quiet suns, it turns out, has room for the ghosts of the loud ones. Even the aristocrats of tonight's sky, the doomed bright celebrities, get to join the long era in the end as embers of a different making, ringed by whatever world survived or arrived, keeping small warm places going deep into the crowded seasons. Nothing in the universe's plan wastes a sun. The future is not somewhere else. It's also here, in this system, around this star, in eras with our address on them. And if life is stubborn anywhere nearby, 10 trillion years from now, the warm ring of the thing that used to be our sun is, quietly, on the map of places it could call home. The house doesn't close when the first fire dies. The house banks its coals, and the long night it's preparing for is exactly the era when, tonight's whole story insists, the neighborhood finally fills. And before the honesty hour, one more thought that pulls tonight's title tight, because I've been saying the first one's awake all night, and the word awake is carrying more weight than you may have noticed. Consider what we've actually found these last few decades in our own small system. Water, everywhere, hidden. The buried ocean of Europa, holding perhaps twice the liquid water of all Earth's seas beneath its cracked shell. The salt geysers of Enceladus, venting an ocean into space where a spacecraft has already flown through and tasted them. The brine reservoirs of Little Ceres, the possible deep sea of Pluto that may have steered the heart into place. The hinted waters of Eris, the suspected oceans inside half a dozen moons. Our one system, sampled honestly, turns out to be a house full of covered pools, dark, mineral-rich, warmed from below, some of them stable for billions of years, and every one of them is exactly the kind of place where, on Earth, at deep-sea vents in the sunless dark, life does perfectly well. Nobody knows if anything lives in those buried seas. But run the pattern across the galaxy, because ice-covered oceans don't need a friendly star, or a temperate orbit, or good cosmic timing. They self-heat, under any sun or none, around the embers and the giants and the rogues drifting starless between systems. By sheer count of venues, the universe's most common habitat in this era, and perhaps every era, is probably not a blue world under a warm sky. It's a black ocean under a mile of ice. And if simple life takes hold in such places even occasionally, then the present universe may already be quietly, extensively inhabited, and the census of the living cosmos at this hour would read almost entirely asleep. Microbes in the dark, metabolizing minerals, going nowhere, seeing nothing, needing nothing, for billions of years at a stretch. Life as a held breath. In that picture, tonight's title becomes literal in a way I didn't promise at the start. we may not be the first life at all, not remotely, and still be the first ones awake, the first patch of matter anywhere to open its eyes, look up through a transparent sky rather than a roof of ice, and see the rest of the house. The difference between us and a universe of sleeping oceans isn't chemistry. Most of it we share. It's the window. We happen to arise in one of the rare rooms with a view, and the view, as we established under the empty row of seats, is the whole show. Perhaps that's the real shape of this hour of cosmic time. Not one lamp in a vacant house after all, but one reader awake in a house full of sleepers. The only one with a candle lit, the only one at the window, keeping, without ever being asked, the whole household's first watch. Honesty hour now before the close, because tonight's idea is beautiful, and beautiful ideas are exactly the ones that deserve the hardest look. Is the earliness argument actually true? The candid answer is that it's one serious possibility among a few, and the alternatives deserve their minute. The first alternative we've already met. It's the hinge itself. If red dwarf worlds can't hold their atmospheres against those flaring youths, the great future mountain deflates and our timing becomes unremarkable. Mid-pack rather than early. The telescopes are on it, and within years the answer should firm up, and it's worth savouring that the deepest question of tonight, when does life happen, currently hangs on weather reports from 7 small worlds 40 light years away. The second alternative is humbler. Maybe life, simple life, is already everywhere and always has been, quietly, in the subsurface oceans we keep finding, under the ice of moons, in the buried seas of dwarf planets, and the universe's biological age began long ago, invisibly, with nothing to show a radio telescope. In that picture, we're not the first life, just, perhaps, the first noise. Early in a different, narrower way. The first to build antennas rather than the first to exist. Tonight's argument survives in modified form, but the poetry shifts. And the third alternative is the deep one, the anthropic riddle. And I'll give it to you gently because it's the kind of thought best handled at low volume. If the great age of life is really 10 trillion years away, a skeptic asks, then the overwhelming majority of all observers who will ever exist live in that far era, and you should statistically expect to be one of them, and you're not. So doesn't your own early birthday count as evidence against the whole picture? It's a genuinely strange argument, reasoning from the timestamp of your own existence, and philosophers have fought about its rules for decades without settling them. Perhaps it means the future mountain isn't there. Perhaps it means observers like us, carbon creatures around yellow stars, are a different reference class from whatever the far future holds. Or perhaps being early is just what being early feels like, and someone has to be the statistical outlier, and every early observer in every young universe has this exact 3 a.m. argument with themselves, and the ones who happen to be first are, by definition, the ones who lose it, and are right anyway. The honest summary is this: The clocks are real, the birth curve is real, the trillion-year stars are real, the 92% is real. What remains open is the hinge and the riddle, and they're being worked with real instruments on real schedules. Tonight's idea isn't a settled fact. It's something better for our purposes, a live possibility currently unfalsified that the silence over your roof is the silence of earliness, and no one on Earth tonight can prove it wrong. You might wonder, reasonably, whether tonight's idea can ever graduate from beautiful argument to tested science, whether firstness is even the kind of claim evidence can touch, and the answer, encouragingly, is yes, along at least 3 roads, all under construction right now. The first road we've named already, the Red Dwarf Hinge. The Webb telescope is spending precious hours this very season measuring whether the small worlds of the TRAPPIST system kept their atmospheres, and each verdict tilts the future mountain, solid air on ember worlds, and the trillion-year age of life firms up, bare scorched rock across the board, and it deflates. That's data, arriving on a schedule of years. The second road is the biosignature census. The next generation of observatories, the giant ground telescopes now rising in Chile, and a planned space telescope whose entire mission is habitable worlds, will read the atmospheres of dozens of nearby Earths for the fingerprints of biology. Oxygen out of balance, methane where it shouldn't persist, the gases only life maintains. And when those fingerprints start arriving, the crucial detail for tonight won't just be how many worlds live, but which ones, because every host star wears its age. If living atmospheres show up preferentially around older suns deep into their runs, that's the signature of a universe where life needs its full billions and started long ago, less room for firstness. If the living worlds skew young, recent, still in their run-ups, that's the signature of a cosmos that has only just begun to wake, and our earliness becomes measurable demography rather than philosophy. And the third road is the strangest and cheapest, the search for anyone older, because the strongest disproof of tonight's whole idea would be a single confirmed elder. One artifact, one beacon, one unambiguous techno-signature from a civilization with a billion-year head start. Every year, the surveys widen, and every silent year is one more quiet data point. Never proof, absence can't prove absence, but weight, gathering weight on the side of the empty morning house. Which means tonight's question sits in the rarest and best category an idea can occupy, poised, live, and answerable within lifetimes now running. Think of how few of the great questions can say that, and notice with some pride in our strange little species what it took to get it there. To even ask whether we're first required knowing the universe has an age, a discovery not yet a century old. It required the star formation history, assembled from decades of deep fields. It required a census of planets, unimaginable before the 1990s, and the lifespans of red dwarfs, and the biography of Earth's own slow oxygen, and instruments that can smell the air of worlds 40 light-years away. Every generation before ours could only feel the silence. Ours is the first that can interrogate it, put a clock in its hands, and expect an answer back. If we are indeed the first ones awake, then it's fitting, in a way that borders on poetry, that the first thing we did upon waking was invent, from scratch, in a single century, all the tools needed to check whether anyone else's alarm had gone off yet. There's one more way to hold tonight's idea, and it's my favorite, because it turns the whole thing from cosmology into something you can feel in your chest. Think about what firstness has meant every time it has happened inside our own world story, because it has happened over and over, and the pattern is always the same. The first photosynthetic microbes spent their eons in a world that had no one to notice them, flooding the air with oxygen for 2 billion years, changing everything for creatures they could not imagine and would never meet. The first fish to haul itself onto mud found a continent of total silence, no bird song, because there were no birds, no rustle of leaves, because there were no leaves, an empty stage it could not have known was a stage. The first humans across every horizon, the ridge, the strait, the ocean, arrived to lands that held no footprints, and lit fires in valleys where fire had never been carried, and none of them, not one, knew they were first, or what their firstness would mean. That's the constant. The first ones never get to know. They experience only the quiet and the work, the emptiness that reads as loneliness from inside and as beginning from any distance at all. If tonight's argument is right, we're inside that exact experience at the largest possible scale, the valley with no footprints, the stage before the play, and the fact that it feels like loneliness rather than like dawn is not evidence against the dawn. Feeling early and feeling alone are, from the inside, the same feeling. Every firstborn in history has mistaken one for the other at 3 in the morning. And if we ever needed a companion for the feeling, the universe has already provided one, in the sky, every night. And tonight you know how to read it. The stars themselves were first, once. Before the first star, the universe spent its dark ages as cooling gas. 100 million years of absolute night, no light anywhere but the fading glow of the beginning, and then somewhere, in one unrecorded place, gravity finished its first slow work, and the first star lit. One. Alone. A single point of fusion in an infinite dark, with no witness, no sky full of siblings, no category even, the first member of a class of things that would eventually number in the billions of trillions. That star had no way to know what it was starting. It burned its brief burn and died, and seeded, as we learn tonight, the atoms of everything after, and the universe filled, over the eons, with so many of its descendants that its kind of loneliness became permanently extinct. No star will ever be alone again. That's what firstness buys in the end, not glory. The first star has no name and never will. It buys the end of the condition. The first ones absorb the loneliness so completely that no one after them ever has to feel it. And if that is our seat in the story, the seat with the empty row, then it comes with the oldest job in the universe, the one the first star did without knowing: burn anyway, seed everything, let the crowd come after. Now, as we finally come to the end of tonight's early morning, let's fold it all together once, slowly. We began with a silence that has always been read as a verdict, and we asked the one question the verdict never considers: what time is it? And the clocks answered, all of them, the same way. The universe is 13.8 billion years old and will make stars for 100 trillion, 12 minutes past midnight on the year's first day. The ingredients of worlds took generations of stellar furnaces to exist at all, and Earth formed close behind the earliest comfortable moment, ahead of 92% of the Earths that will ever be. The longest-lived stars, the little red embers that own 3/4 of the sky and essentially all of the future, have not yet begun their prime, and the mathematics of it all, published, argued, unrefuted, says the great age of life likely lies trillions of years downstream, with our era 1,000 times too early for the crowd. We visited the crowd in their golden, forgetful age, rich in company, robbed of the view, and we counted our own tickets, the empty row, facing everything. We stress-tested the idea honestly, the red dwarf hinge, the quiet microbes alternative, the strange arithmetic of birthdays, and found it standing, a live possibility no one can currently defeat. And we ended with the first star, burning alone in the dark ages, doing the job of the first ones, which is simply to burn, and to seed, and to make its own loneliness extinct. So here's what I'd like you to take down into sleep on this night in the universe's first hour. Every unsettling headline about this idea, and the one that inspired tonight was no exception, reaches for the word alone. The unsettling reason the sky is quiet, the haunting possibility that no one else is out there. And tonight has been, in the end, one long, gentle disagreement with that framing, because early is not alone. Early is the room before the party, the valley before the footprints, the dark before the first star, and every one of those, given time, filled. The silence over your roof tonight is not a wall, it's a waiting room, and the wait is not even ours to endure. It belongs to the universe, which has all the time there is and has barely started spending it. Somewhere in the deep future, if the clocks and the curves are right, there are more living worlds than there are stars in our sky tonight. None of them born yet, all of them coming. And everything we are, this world, this hour, this voice, your breathing as it slows, sits at the very beginning of that story, in the quietest, clearest, most unrepeatable seat in the house. Thank you for spending this night and this whole first month of nights out here at the start of everything with me. The house is quiet, the stars are early, so are you. Sleep well tonight, first one. Good night. There's one more way to hold tonight's idea, and it's my favorite, because it turns the whole thing from cosmology into something you can feel in your chest. Think about what firstness has meant every time it has happened inside our own world story, because it has happened over and over, and the pattern is always the same. The first photosynthetic microbes spent their eons in a world that had no one to notice them, flooding the air with oxygen for 2 billion years, changing everything for creatures they could not imagine and would never meet. The first fish to haul itself onto mud found a continent of total silence. No birdsong, because there were no birds. No rustle of leaves, because there were no leaves. An empty stage it could not have known was a stage. The first humans across every horizon, the ridge, the strait, the ocean, arrived to lands that held no footprints, and lit fires in valleys where fire had never been carried, and none of them, not one, knew they were first, or what their firstness would mean. That's the constant. The first ones never get to know. They experience only the quiet and the work, the emptiness that reads as loneliness from inside and as beginning from any distance at all. If tonight's argument is right, we're inside that exact experience at the largest possible scale. The valley with no footprints, the stage before the play, and the fact that it feels like loneliness rather than like dawn is not evidence against the dawn. Feeling early and feeling alone are, from the inside, the same feeling. Every firstborn in history has mistaken one for the other at 3 in the morning. And if we ever needed a companion for the feeling, the universe has already provided one. In the sky, every night, and tonight you know how to read it. The stars themselves were first. Once, before the first star, the universe spent its dark ages as cooling gas. 100 million years of absolute night. No light anywhere but the fading glow of the beginning, and then, somewhere in one unrecorded place, gravity finished its first slow work, and the first star lit. One, alone. A single point of fusion in an infinite dark, with no witness, no sky full of siblings, no category even. The first member of a class of things that would eventually number in the billions of trillions. That star had no way to know what it was starting. It burned its brief burn and died, and seeded, as we learn tonight, the atoms of everything after, and the universe filled over the eons with so many of its descendants that its kind of loneliness became permanently extinct. No star will ever be alone again. That's what firstness buys in the end. Not glory. The first star has no name and never will. It buys the end of the condition. The first ones absorb the loneliness so completely that no one after them ever has to feel it. And if that is our seat in the story, the seat with the empty row, then it comes with the oldest job in the universe, the one the first star did without knowing: burn anyway, seed everything, let the crowd come after. And if we are the early ones, there's a role waiting for us that nobody assigned and nobody can take away. One that follows from everything tonight has shown. And I want to spend a quiet minute on it, because it may be the most dignified answer to the silence anyone has proposed. We could be the archivists. Think about what our seat in time allows that no later seat ever will. We can see the beginning. The first light of creation still hums in our sky, measurable by any decent antenna, and we've photographed it in exquisite detail, the baby picture, the seed catalogue of everything. We can see the deep field, 100 billion galaxies in every direction, the full census of what exists. And we can watch the cosmic dawn directly, the Webb telescope catching the first galaxies in the act of forming. Every one of those sites has an expiration date. The expansion, as we learned on our Great Attractor Night, is carrying the evidence over the horizon era by era, the distant galaxies first, then the nearer ones, until, in the deep future, our story keeps visiting, the sky forgets its own history completely. The crowds of the red dwarf eons, whoever they are, will inherit a universe that cannot tell them where it came from, unless someone wrote it down. Unless the first ones awake, the only generation of minds that ever gets to live while the whole story is still visible, made the record, the maps, the measurements, the images, the great catalogue of 100 billion galaxies compiled while there were still 100 billion galaxies to catalogue. It sounds grandiose until you notice we've already started. Every deep field archived, every survey published, every map of the oldest light is, whether its makers thought in these terms or not, a letter to the far future, the only eyewitness account of the dawn that will ever exist. In 10 trillion years, if anything anywhere keeps libraries, the crown jewels of every library in the universe will be records made now, in this first hour, by whoever happened to be awake with the lights still visible. That's not a consolation prize for loneliness. That's the most exclusive job in the history of existence, and it fell to us by accident of birth. The first ones don't just get the view, they get to be the only ones who can prove the view was ever there. And here's the final gentle turn of tonight's long idea, the one I've been saving, because it answers the question that the archivist thought quietly raises. Even if we make the record, who could ever receive it? The candid answer from our Alpha Centauri night still stands. Matter doesn't travel. The distances forbid it. No library ships are crossing to the red dwarf eons. But light travels. Light always travels, and light, once emitted, is astonishingly hard to destroy. Every photon that leaves the Earth and slips past the atmosphere simply keeps going, thinning, stretching, but persisting, crossing the void at the only perfect speed there is, forever. Which means something strange and rather beautiful is true about this evening. The light of every day Earth has ever lived is still out there. All of it, an expanding shell of images racing outward at the speed of light. The dinosaurs last afternoon passing through some remote cluster of galaxies tonight. The light of the year you were born just now washing over the nearest few dozen stars. Earth broadcasts its whole biography outward, continuously, unstoppably, whether anyone tunes in or not, and so does every star, every world, every era. The universe doesn't discard its past. It mails its past outward at the cosmic speed limit permanently. And the only question is whether anyone is ever positioned to read a given page as it sweeps by. Almost certainly, almost everywhere, no one is. The pages sweep through empty rooms as our whole journey together has taught. But the letters never stop being sent, and unlike us, they never age, never tire, and never arrive at a last horizon they can't cross into someone's patient telescope. If the crowds of the deep future ever wonder about the first hour, some fragment of the first hour will still, in principle, be in flight somewhere, faint beyond faintness, the oldest photons of the living era still falling through the dark, like the last snow of a vanished winter. We are not just the first ones awake. We are, at this very moment, the authors of the oldest light the age of life will ever have sent, and tonight's edition is already on its way. This night, this quiet hour, your slowing breath in a dark room on a small blue world, translated into a shell of faint radiation. One light day wide by tomorrow, one light year wide by next summer, spreading, unrecallable, toward every future there is. Nothing that happens in the light is ever entirely lost. It's only ever, like everything else tonight, very far away and traveling. We watched the first star ignite tonight alone in the fog of the dark ages. So before we close, symmetry asks us to attend one more ignition, the one at the far end of the year, because someday, 100 trillion years from now, somewhere in the merged and reddened remnant of some galaxy, the universe will form its last star. And that scene deserves a witness too, even an imaginary one, even this far in advance. Picture the era it happens in. The great red dwarf ages are winding down at last. The sky of that time long since gone strange, a thin scatter of dim embers and cooling corpses in an otherwise empty dark. The other galaxies' ages gone beyond the horizon. The birth clouds nearly all spent. Star formation, once a torrent of thousands per second across the cosmos, has slowed to a drip measured in eons, and then, in the era we're visiting, to this, a final cloud, the last pocket of unspent gas anywhere, cooling and falling inward exactly as its trillion predecessors did. The ancient recipe followed one final time. It will not know its last, any more than the first knew it was first. Gravity will gather it, the center will warm, the old threshold will be crossed, and a small red star, it will surely be a small red one, the thrifty kind, will quietly switch on the final fire and begin its trillion years of patient shining with nothing around to remark on the milestone. And here's the thought that makes this scene belong to tonight rather than to some melancholy elsewhere. If tonight's argument is right, that last star will be born into the universe's old age of life, not its emptiness, the mountain on the graph long since climbed and descended, quadrillions of worlds worth of stories already lived by then, and its little dowry of planets condensed from the richest gas there ever was, will have a trillion years of warmth to add a few last stories more. The year of the stars ends the way it began, with a single small fire in the dark, but between the two ignitions, first and last, stretches the entire season of everything, every world, every ocean, every mind, every night like this one. And the whole of it, the complete age of light and life from end to end, sits downstream of where you're lying right now. You are closer in time to the first star than to the middle of the story, closer to the dark ages than to the crowds. When the last star finally lights, this night of yours will be deeper in its past than the first star is in ours, and some drowsy mind of that final era, if any such exists to drowse, may be told about the early ones, the strange first hour when the galaxies were all still visible and every listener was new. Now, as we finally come to the end of tonight's early morning, let's fold it all together once, slowly. We began with a silence that has always been read as a verdict, and we asked the one question the verdict never considers: what time is it? And the clocks answered, all of them, the same way. The universe is 13.8 billion years old and will make stars for 100 trillion, 12 minutes past midnight on the year's first day. The ingredients of worlds took generations of stellar furnaces to exist at all, and Earth formed close behind the earliest, comfortable moment, ahead of 92% of the Earths that will ever be. The longest-lived stars, the little red embers that own 3/4 of the sky and essentially all of the future, have not yet begun their prime. And the mathematics of it all, published, argued, unrefuted, says the great age of life likely lies trillions of years downstream, with our era 1,000 times too early for the crowd. We visited the crowd in their golden, forgetful age, rich in company, robbed of the view, and we counted our own tickets, the empty row, facing everything. We stress-tested the idea honestly, the red dwarf hinge, the quiet microbes alternative, the strange arithmetic of birthdays, and found it standing, a live possibility no one can currently defeat. And we ended with the first star burning alone in the dark ages, doing the job of the first ones, which is simply to burn and to seed and to make its own loneliness extinct. So here's what I'd like you to take down into sleep on this night in the universe's first hour. Every unsettling headline about this idea, and the one that inspired tonight was no exception, reaches for the word alone. The unsettling reason the sky is quiet. The haunting possibility that no one else is out there. And tonight has been, in the end, one long, gentle disagreement with that framing, because early is not alone. Early is the room before the party, the valley before the footprints, the dark before the first star. And every one of those, given time, filled. The silence over your roof tonight is not a wall, it's a waiting room, and the wait is not even ours to endure. It belongs to the universe, which has all the time there is, and has barely started spending it. Somewhere in the deep future, if the clocks and the curves are right, there are more living worlds than there are stars in our sky tonight. None of them born yet, all of them coming, and everything we are This world, this hour, this voice, your breathing as it slows, sits at the very beginning of that story, in the quietest, clearest, most unrepeatable seat in the house. Thank you for spending this night and this whole first month of nights out here at the start of everything with me. The house is quiet, the stars are early, so are you. Sleep well tonight. First one, good night.